All right, hi guys. Thanks for checking in here. This is going to be our first of many video lessons. So, working on this integration by parts here from Monday and Tuesday before we were sent home. And we did our proof here on Tuesday when I was back using U's and V's. I know I sent you guys a link to a video that had the proof with function notation f of x and g of x. I prefer this U and V stuff. And we have that the integral of u dv equals uv minus the integral of v to u. Okay, here it is a little bit cleaned up, not in my handwriting. Now the concept again is that we have to pick a u and we have to pick a dv. Now when we pick those, and you look at our formula here, u, we've already picked it. V, we get that by integrating what we've chosen for dv, minus the integral of v. Okay, how do we get v? Again, by integrating dv. du, which we have to get from differentiating u. Okay. So the concept is we've got to pick some u and v, a u that's easy to differentiate and a dv that's easy to integrate. Okay, and we can see that in this example here. Okay, x e to the x dx. We picked u to be equal to x. Now x is easy to differentiate and integrate. But differentiating produced a simpler result. The derivative of x is 1. Okay? Now we picked dv to be e to the x dx. So when we integrated both sides, okay, we end up with v equals e to the x, which is just as simple as was it before. And that's not a difficult one. Natural log of x. Okay. This choice was obvious, right? I mean, we're trying to find the antiderivative of natural log of x. We know its derivative is 1 over x. So we let u equal the natural log of x. We could not have let dv equal the natural log of x because we don't know what its antiderivative is. That's what we're trying to figure out. So dv just ended up being 1 dx. Okay. Quick reminder, you can always check your answer by differentiating. All right, let's try another one. This also has a natural log of x in it, and it has that x to the 6th up front. So let's get this set up. We need 4 things. We need u, dv, we'll need a du, and we'll need a v. So taking a look at this and trying to place them appropriately, and there'll be trial and error with this, you guys. You'll pick something, you'll try it, and you'll think that doesn't look really any better than what I had before, or we'll try something and we'll say that's an improvement. That looks much better. So if I think about x to the 6th, if I put x to the 6th here, the derivative is 6x to the 5th. That's not too bad. Okay. If I put the x to the 6th here, its antiderivative is 1/7 x to the 7th, which isn't too bad either. So that one's pretty good in either place. However, our natural log of x, I think, is going to dictate where we want to go with this. The natural log of x, okay, if we take the derivative of that, is 1 over x. Now, I'm skipping this step. I'll write it back in here. Du dx equals 1 over x. If u equals the natural log of x, du dx is 1 over x. Solving for du, we get 1 over x dx. Why didn't I want the natural log of x right there? Well, here I would have had to integrate it. I would have needed to find the antiderivative. What's the antiderivative of the natural log of x? We just did that. It's right here. It gets more complicated. We don't want things to get more complicated. We want things to get simpler. That's why we're going to put the natural log of x right there. So I know that's where I want that. If I put an x to the 6th with it, when I differentiate, I need to use the product rule. That doesn't sound enticing to me at all. So I'm going to put the x to the 6th dx right there. So then what we do is we integrate this, and you'll get to the spot where you can skip this step in writing. We're taking the integral of dv, which is really 1 dv, which is v, and we're taking the integral of x to the 6th dx. That's why our dx needs to be with that so we can actually integrate it. And as I've mentioned, this is 1/7 x to the 7th. So now let's set up our integration by parts formula. So this is going to equal I'll slide down here just in case it gets long and run into that. Okay, how's it go again? U, V, right? So I'm just going right off this formula. U times V. So my U is the natural log of X. My dV, or my V, excuse me, is 1/7 X to the 7th. So U times V is this times this. I'll write them in the other order, just because I like my natural logs to be at the end. UV minus formula, integral of V du. Integral V du. And we can see here why this works out pretty well, because this is going to simplify nicely. I don't have to do anything with what's up front. Now this will simplify. I'm going to put the 1/7 in front. We have an x to the 7th in the numerator. We have an x in the denominator. That's just an x to the 6th. And now I have something that I can integrate. I can find the antiderivative of this. So we have 1/7 x to the 7th natural log of x minus 1/7. What's the antiderivative of x to the 6th? We've already done that one. 1/7 x to the 7th. Need my plus c on there. So we end up with 1/7 x to the 7th natural log of x minus 1/49 x to the 7th plus c. Okay, I hope that feels good to you guys. Again, this takes lots of practice. Once you get the hang of it, not too bad at all. Let's try another one. The integral of e to the x sine of x dx. So let's get this thing set up. All right, so time to place things. E to the x. I could go either way with that. The derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. That could go either way. How about sine? Well, the sine, derivative of sine is cosine. The antiderivative of sine is negative cosine. So again here, really, I feel like we could go either way. So let's pick something to try. Let's pick this to be our e to the x. So then our du, so I'm going to take the derivative, du dx equals e to the x, du equals e to the x dx. I'm going to let my dv be the sine of x dx. Okay, we got to put everything in there. Don't forget your dx. Now we integrate this. And the derivative, or excuse me, antiderivative of the sine of x dx is going to be the negative cosine of x. All right, let's set it up. So this is equal to, almost forgot my dx. All right, u times v. I'm going to write it in the other order. Minus the integral of v du. All right, so let me evaluate this. Did I get something easier to take the antiderivative of? I'm looking at my original, and I'm looking at my new integral, and I don't think I've come up with anything easier. So does that mean I've gone wrong? That this isn't going to work? This integration by parts is just not helpful here? Not the case at all. Actually, when I look at the original, I look back at this one, I think I kind of almost ended up back where I started from. And it makes me wonder, I ended up close to where I'm back to where I started, but I have a cosine instead of a sine. What if I did it again? Here's a quick switch. I'm just going to slide this out and make that a plus right there so they cancel. Let's set up another integration by parts. All right, and I'm going to do the same thing I did last time. I think I think this feels promising. Okay. This time dv is the cosine of x dx. Okay. And our antiderivative of that is going to be sine of x. So now we have this equals, don't lose what you've already done, minus, nope, it's a plus now because we moved that negative. I got to put a parentheses. Now I'm doing integration by parts just for this. So here we go. U times V minus the integral of V du. Okay, so that's sine of x times e to the x dx, which I'll just switch back to this order. All right. So I did get back where I started from, didn't I? So does that mean I'm just going to go in this endless loop over and over again? You're right, I would. If I just continued to do this, I'd be bouncing back and forth between sines and cosines, and I wouldn't get anywhere. However, the key to this problem, and this is really cool, what is this equal to? It's equal to the original. I'm going to move this to a new page, and we're going to see how that's helpful. All right, let's get that guy out of the way. There we go. What would happen if I added the integral of e to the x, sorry I missed an x in there, sine of x dx on both sides? Oh, I missed it over there too. All right, what do we have on the left side? We have 2 times the integral of e to the x sine of x dx equals the negative cosine of x e to the x plus e to the x sine of x. What are we trying to find again? We're trying to find this. Well, we have an equation where we have 2 of those equals something else. How do we solve for this? I divide each side by 2. That gives me the integral of e to the x sine of x dx, which is exactly what I want, equals this. Now I'm just going to rearrange this so it looks a little bit nicer. I'm going to write it as 1/2, and I'm going to switch the order here, e to the x sine of x minus e to the x cosine of x. Even here, if you wanted to factor out an e to the x, you could write it as 1/2 e to the x parenthesis sine of x minus cosine of x. I mean, we can rearrange it quite a bit. That looks at least a little cleaner than what I had before. So here we end up with a really interesting twist off our integration by parts. We did it twice, got back to where we were, and we said, let's just solve that equation. Let's add it over and divide by 2. There it is. All right, that's going to conclude this video. We've got more from integration by parts to come.